get to learn some of the rules for finding antiderivatives. So we start with properties of definite integrals. So if you're doing the integral from a to b of f of x dx, that's going to be the opposite of the integral from b to a of f of x. So if a is less than b, you're going from left to right. And then here, you would be going right to left. So we have to multiply that by a negative. This comes in really handy if you have a part that is below the axis and it's starting to mess with your brain. You can simply go, okay, or if you're having to go from right to left, okay, you can just do the opposite and go left to right. So like, let's say that you had the integral from 2 to negative 1 of f of x dx. That can get really confusing, especially if part of this is below the axis and all that kind of stuff. So you can just go, okay, well, that's the opposite of the integral from negative 1 to 2 of f of x dx. And that's, for most things that we're going to do, that's going to feel more natural. It feels more natural to go from left to right than from right to left. Another property that comes up occasionally, not a ton, but occasionally, the integral from a to a of f of x dx is 0. Why? Well, because the integral gives you the area under the curve down to the x-axis, and if you start at a and you end at a, you don't have any area. If you have a constant multiplied times a function, just like with derivatives, you can simply factor that out. So if you have the integral from a to b of a constant times f of x, that's equal to the constant times the integral from a to b of f of x dx. This will occasionally make things a little nicer within your integrand if you can factor something out. Again, just like with derivatives, we can do this term by term. The integral from a to b of f of x plus or minus g of x dx is the sum or difference of the integral of each of those functions individually. And again, that's just like what we did with derivatives, where if we had a polynomial especially, or we had anything where we had multiple terms, we just did it term by term. The same applies for integrals. This next one is really interesting. It says that the integral from a to b of f of x dx plus the integral from b to c of f of x dx is equal to the integral from a to c of f of x dx. And everybody is really happy with that. Don't worry about drawing this because I'm going to erase it and draw multiple parts. If it's like this, a, b, c, you've got f of x like this. Everybody's perfectly happy with that when it's like this, right? The integral from a to c would be the integral from a to b plus the integral from b to c. You're just adding those two together. People sometimes freak out when it's like this. What if the order was a, then c, then b? Is this still true? Well, if I took the integral from a to b, that would be all of this area, right? And if I did the integral from b to c, since I'm going from right to left, it's going to subtract that. And I end up with the integral from a to c. It didn't occur to me that students didn't realize when I was first teaching this that they were always like, yeah, B's got to be between A and C was in their head someplace, and it doesn't. It can be in any order. A doesn't even have to be the one that's furthest to the left. A could be the one that's furthest to the right, and it's still true. Again, occasionally that's a very helpful thing. This one, you occasionally get asked questions about this, but if you know the minimum value of a function, and that should be on the closed interval from A to B, not just, over its whole domain, and you multiply that times B minus A, you're taking the least height and multiplying it times the width. Well, the integral's got to be at least that much, right? Could be more. Depends on what the function is. And likewise, if we take the maximum of f on the interval from A to B, multiply it times B minus A, the integral will be either less than or equal to that amount. This can, in some cases, it's helpful for you to kind of think about, all right, this, let's say I went from 2 to 7, so I have a width of 5, and the maximum height is 10, and somehow I got 63 as my answer. Well, I know that can't be right, because I've got a width of 5 and a maximum height of 10. If I get 63 as my answer, that's too much. The maximum should be 50. Okay, so occasionally you get asked questions about this, but this is actually more helpful for you thinking about, is my answer reasonable or not? And last but not least, if f of x is greater than or equal to g of x on the closed interval from A to B, then the integral from A to B of f of x dx is either greater than or equal to the integral from A to B of g of x dx. If one of them is actually higher than the other on the same width interval, it should have more area underneath it. All right. So let's take a look at these problems. It gives you some information about the value of different definite integrals. And then it says, find each of the following if possible. You're like, uh-oh. I hate it when they throw in things like that. Some of these are not going to be possible. Some of them are going to be real straightforward. So for f of x, we have the integral from -1 to 1 and the integral from 1 to 4. And for h of x, we have the integral from -1 to 1. So let's take a look at each of these. So the integral from 4 to 1 of f of x dx, that should be the opposite of the integral from 1 to 4 of f of x dx. So that's the opposite of -2, and it is +2. What about the integral from -1 to 4 for f of x? Well, I know the value of the integral from -1 to 1 and the value of the integral from 1 to 4. So I should be able to just add those two together. So this would be the integral from -1 to 1 of f of x dx plus the integral from 1 to 4 of f of x dx. So that'll be 5 plus -2 is 3. All right, what about the integral from 0 to 1 of f of x dx? I know that the integral from -1 to 1 of f of x dx is 5. Does that mean that the integral from 0 to 1 of f of x dx is equal to 2.5? No, not necessarily, right? So this one is not possible. You could do this if they gave you one additional piece of information. If they told you that f was an even function, meaning the part to the left of the x-axis and the part to the right of the y-axis are exactly the same, they're mirror images of each other, then it would be 2.5. But you would have to have that additional piece of information. All right, so for this one, the integral from -1 to 1 of 2 times f of x plus 3 times h of x all dx. Well, that would be the integral from -1 to 1 of, I'm going to pull the 2 out in front, 2 times f of x dx plus 3 times the integral from -1 to 1 of h of x dx. And we have those things, so this is going to be 2 times 5 plus 3 times 7 is 31. All right, for number 5, this is one that students sometimes struggle with. It's easy if you split them up. So if I do the integral from -1 to 1 of h of x dx plus the integral from -1 to 1 of 3 dx. The integral from -1 to 1 of h of x dx is 7. The integral from -1 to 1 of 3, that's a constant function. Its height is always 3. And what's its width? 2. So this is 3 times 1 minus -1. That's where the 2 comes from. So that's 13. So what I want you to notice there is that the integral from -1 to 1, you don't need to write this, of h of x, wow, this is really unhappy with me this morning, plus 3 dx is not the same thing as the integral from -1 to 1 of h of x dx plus 3. Two entirely different things. Here, 3 is part of the integrand. Here, 3 is just a tack on at the end. Not at all the same thing. Which is why it's important that you put the dx when you're writing these out on the AP exam. Sometimes if you leave the dx out, it's not clear whether you meant, so if you wrote the integral from -1 to 1 of h of x plus 3, well, which one of these two did you mean? It's really unclear. So be careful about that. And then the integral from -2 to 2 of h of x dx is not possible. We don't know anything about what happens outside of -1 to 1 for h of x. All right, page 2. So going back to basic geometry for just a second, if we know the area of a rectangle and its base, we can find its height. right? The height would be the area divided by the width or the base. If the top of the rectangle, and I have rectangle in quotes for a reason, it's not a rectangle anymore, is a curve, and we divide the area by the base, we get the average height. In other words, we're getting a value, and I'm going to just sort of estimate it, so that if I melted it down and poured it over here, this extra part would fill in this gap. So this would be your average height. Bless you. So if that curve in this picture is described by an integrable function, then the average value of f is equal to the integral from a to b of f of x dx over b minus a. b minus a will be the base, and the integral from a to b of f of x dx will be the area. Be careful. Do not confuse this with average rate of change. They sound a lot alike. Average rate of change is f of b minus f of a over b minus a. This is the average value of a function. It's giving you the average height, not the average rate of change. And not only this, but if f is continuous on the interval from a to b, then at some point c in that interval from a to b, the average value of f is equal to f at c. In other words, someplace in here, like here, right, this would be my c value, at least once. It could happen multiple times. So let's do this problem. Find the average value of f of x is equal to 7 minus x squared plus x on the closed interval from 0 to 3. And then find where on the interval does f take on this value. And I didn't write a note to myself that I should use a calculator, so let's try this without. So the average value of f is going to be equal to the integral from 0 to 3 of 7 minus x squared plus x dx all over 3 minus 0. So, I'm trying to remember, I apologize. It's one of the problems that I have with teaching AB and BC. I get confused sometimes about what we've done so far. Have we done rules for finding antiderivatives, like the power rule and that sort of thing? Okay, then let's do this on a calculator at this point. So the integral from 0 to 3 of 7 minus x squared plus x, all with respect to 2x. That comes out to be the very nice 16.5 over 3, which is 5.5. So that's the average value of that function, which when you think about it is pretty cool, because Normally when we think about finding averages, we think about adding a whole bunch of numbers together and then dividing by how many there are. This lets us find out the average of something where there's an infinite number of points. I think that's cool. All right. And then we're going to let 7 minus x squared plus x be equal to 5.5. That should happen at least once. So clearing out all this other stuff that's in the way. I'm going to go ahead and subtract the 5.5. So that'll be 1.5 minus x squared plus x. And I want to find the 0. And before I graph it, I only want to look between 0 and 3. So I'm going to set an appropriate viewing window. Remember, that's one of the things that you're supposed to be able to do. And I'll scale that by 1s. And since I'm looking for 0s, I'll just real quick change that from -10 to 10 to -1 to 1. And apparently there's only one place it looks like it's about 2.87. Let's see if that's at all right. Find the 0. Oh, sorry, 1.87, not 2.87. Oh, so for my left bound, I'll use 1. For my right bound, I'll use 2. What did I say, 1.87? I think I overestimated maybe a little. Ooh, not bad. 1.823. All right. So now we look at being able to understand what is it that an integral will tell us in some actual context. So here, consider a plane flying at a constant ground speed of 120 miles per hour from noon until 6 p.m. That's a long time to be traveling that fast at a constant rate, but we'll let it go. What does the integral from 1 to 4 of 120 dt tell us? What is this going to tell us? Well, this is a rate of change, right? And so the integral should tell us the change in whatever it is that's changing. So the integral from 1 to 4 of 120 dt gives us the change in position man, this is not happy with me this morning. Of the plane measured in miles, always important that you give the units, from 1 p.m. until 4 p.m. If you want to be, really, really complete, you can say on the 3-hour interval from 1 p.m. to 4 p.m., but you don't have to do that. Now, if S of t is the position of the plane at any time t, from t is going from 0 to 6, then its velocity is s prime of t, which is equal to v of t. So then what does the integral from 1 to 4 of s prime of t tell us? Exactly the same thing. So, if we interpret the integrand as a rate of change, f of t, with antiderivative capital F of t, then the integral from a to b of f of t dt is capital F of b minus capital F of a. I can't tell you how many problems on the AP exam I've seen over the years where you can use this idea. Sometimes on the problems that they have, we won't do one today, but sometimes it's easier to think of it this way. Capital F at B is equal to capital F at A plus the integral from a to b of f of t dt. I like this because it reminds me of point slope. F of a, where did you start? Where did capital F start? And then the integral tells me how much capital F changed on the interval from a to b. All right, so let's see if we can find the integral from 0 to pi of sine of x dx using an antiderivative. Well, what can I take the derivative of that would be equal to sine of x? Yeah, negative cosine of x. So what this means is that the integral from 0 to pi of sine of x dx is going to be equal to negative cosine at pi minus negative cosine at 0. What's cosine at pi? Negative 1. So this is going to be the opposite of negative 1 plus, because it's minus a negative, what's cosine at 0? 1. It's 2, which actually we had in a lesson earlier in this unit. I said, given that the integral from 0 to pi of sine of x dx was equal to 2, well, now we've showed that it really is. This is one of the strangest things ever, at least in my opinion. If you took the graph of sine, which has a height of 1 at the most and ends at pi, that this area, if this is y is equal to sine of x, that area is exactly equal to 2. That just seems all kinds of strange, because pi is this long decimal, and I'm like, Okay, but this works out to be exactly 2. All kinds of interesting things start happening at this point. All right, that's all I got for you today.